All right, thank you everyone. So we have time for some questions, but before we go there, this is the link for our survey. I'll be texting that shortly on the chat box, so you should all be able to receive and you can go and fill it in. If you could do that, that would be really appreciated. But moving to the questions, the first area I categorize under regulatory frameworks. So the first one, actually, Sam, if you could take that, will AEMO continue to maintain the same fault levels at the designated fault level nodes? What if those major generation center retire?
Thanks, Babak. These questions are really interesting. The answer, in short, is no. The fault levels of the nodes won't stay the same into the future, and the fault levels themselves, the nodes themselves, may move. That's not to say we're going to move the nodes and change the minimum fault levels quickly or drastically every year, but over time we will need to move them because the energy system is transitioning and it wouldn't make sense to keep them so high in certain areas and so low in other areas. A kind of indication for where we think things may go can come from looking at our 2020 Integrated System Plan. In the appendix number 7 about power system security, we've explained that we see a relationship between future system strength requirements and the construction of renewable energy zones in the national electricity market. So part of our sort of joint planning with transmission networks includes looking at where renewable energy zones will go, where the system will go in the future, and we will have to move the fault level nodes around accordingly. But we haven't yet started to publicly project or give indications of how they might change because, of course, it's very dependent on what happens in the market and with the different generators on the system.
Okay, great. Do you want to take the next one also, alignment of market pricing nodes and system strength nodes?
Certainly. As far as I'm aware, I have not heard of this concept being considered in the regulatory regime. If the question is about aligning pricing nodes with system strength nodes, no, I don't believe that that's being proposed, but I could be wrong. There could be some regulatory discussion happening that I'm not aware of, but as far as I know, no, there is not.
Okay. Julian or Christian, do you want to comment on that?
I know the KIGASI will change the coordination of generation and transmission investment. As looking at putting locational marginal prices that could reflect system strength constraints, but I'm not sure. I'm not involved very much in that project, so I don't know the detail.
Okay, so we perhaps provide a written response in next few weeks and see exactly what it is. All right, let's move on from it. Thanks, Julian and Sam. So the second area I categorize under distribution networks. Alan, if you could take the first question, that essentially the question is that I try to be as faithful as I can to the question, that's saying that it is essentially anything that can be done at the consumer levels, whether there are consumer loads or inverters or batteries, and could it be incentivized?
Yeah, thanks for that. Again, very interesting question. I think the whole issues around system strength on the distribution, I think is, I guess, a bit largely unknown or untested at this point in time. But I think if there are known system strength issues on the distribution network, whether that's on the sub-transmission or the LV distribution, I think it does need to be solved in some way, whether it is a utility type solution or back down into the customer's installation. Typically to date, all of the standards around the small customer connections, that's really driven through the ENA and through, the existing 4777. But yeah, it is a difficult issue, particularly when we start to have to involve the sort of mums and dads. And I think given the complexity around system strength issues, it's not something that we could easily then disseminate that back down to, small customers. Potentially maybe for like the sub-5 connections, potentially there could be something like that. I know Hugh, if he wants to jump in on that, but yeah, I think even for small connections it would be hard.
All right. Okay. All right. Great. Thanks. So the next question, Andrew and Ike, if you could take that based on the studies you've done recently. If the unexpected disconnection of distributed energy resources, meaning rooftop PV, could cause any adverse impact on system strength.
So I guess, Babak, we've been focusing on the impact of this disconnection on system transfer levels, and that's predominantly looking at interconnected transfer limits from SO3 to Victoria. To be honest, we haven't really looked at this in terms of system strength as such, because modelling the DER in the way that we model the larger scale IBR has its challenges. But yeah, certainly we've been looking at it in terms of impact on system limits.
All right. Okay. Thanks. Okay. So the next area I categorize generation mix. The first question, that's actually a fantastic question. The question is that can we operate the future power system with sync-ons and grid-forming inverters only? So the answer to that is definitely yes. From a system security perspective is yes, but obviously there are reliability questions and consideration. As long as they can be addressed, there is not a system security concern. If anyone wants to add anything to what I mentioned. Okay, if none, the next question I would ask Transgrid or PowerLink, if you don't mind. The question is that with almost 2/3 of existing coal-fired generation to retire in next few years, and at the same time rapid increase in harmonic sources being loads and IBR, both polyphonic connected sources, is there any plan to increase the sinks of harmonics as such to have some absorption capability?
Thanks, Babak. I'll go first. So as we talk at the moment, all the framework related to harmonics are with the generator or load connecting. There are responsibilities on NSP to maintain a certain level of harmonics and flickers. The harmonic, how I see the problem, it's very hard to deal as an individual. So I definitely believe that there's a need that the problem of harmonics to be taken at network level. And yes, when coal-fired synchronous generators retire, there will be a need. How do we sync? I also believe that grid-forming inverter technologies will be able to help reducing some of the harmonics or power quality issues in the network. But definitely there's a need to look at harmonic problem from system point of view rather than individual connection point of view.
Yeah, and I mean, that's what I was trying to highlight in my presentation, although I appreciate it was disconnected and then there was a voice recording that power quality, which harmonic is part of it, and protection are quite important and are becoming more important, but they haven't been probably given the attention they should. But the answer to this question, it definitely has a merit, and it's something that we collectively as the industry need to look at. Right, great, thanks. Okay, so moving to the next questions. These are for you, Stephen. Can multiple grid-forming converters from different manufacturers synchronize with each other? If so, how?
Yeah, so the distinction between grid-forming converters and virtual synchronous machines is a very important point. Grid-forming converters don't operate in parallel with each other well, and Tony Morton's presentation this morning gave a good overview of that. If it's a single grid-forming converter, it works well, but when you're interacting with other devices, that's where the virtual synchronous machine layer comes in. So you certainly can synchronize with multiple vendors. It's important to know the characteristics of each and through the modeling exercise, tune each virtual synchronous machine to basically coordinate in the same way. So you don't want one doing too much and one not doing enough. It's all about contributing in a unified and expected way. So that is, again, one of the benefits of virtual synchronous machines, that you can update it or tune it to operate, both now, but then as we all see that the grid's evolving, it's not just a static piece. We also need to have the ability to do that moving forward as the system changes.
Okay, great. All right, so the next question is that does a grid-forming inverter need to overrate its capability? Is it a must, or it's a nice to do to supply extra fault current? And if it's a must, by how much typically it has to be overrated to provide similar contribution or similar performance as a synchronous generator?
Yeah, so it really comes back to an optimization exercise. So if we look at integrating grid-forming converters or virtual synchronous machines from a protections perspective, if you can reduce protection settings, if that's more effective than oversizing your converter, then that's a more cost-effective approach. I guess the challenge is we had synchronous machines first, and the network was developed with the characteristics of synchronous machines in mind, and they have very high fault currents. There's nothing to say that we need those kind of fault levels. However, the inherent system is built for that. So if we have to change too much of that system to accommodate the lower fault contributing devices, then it's a cost comparison. I would say though that because the vast majority of converters to date have been grid following and the commercial drivers have been to provide energy as a service, there's not a lot of value that's been attributed to doing overload. So that's why you see converters typically providing 1.1 per unit overload. But as these needs become more important, vendors can design converters to have, say, our converters 2 to 3 per unit overload, and that can be uprated as well. So the market will really drive what's required there. And just oversizing your inverter, there's a lot of auxiliary equipment that has to accommodate that. So I think inverters with higher overload to have less, coupling transformers, DC backend devices will make sense. So yeah, I hope that answered the question. And then probably just a last point is that it's not all about fault current. When we talk about system strength, there's a number of aspects to it. So the speed of response, fault current's an important factor, but also reducing the impedance to where the voltage source is to where you're connecting. So it's not a one-for-one comparison either. Okay, excellent. Thank you. All right, moving on to the next category. So Sachin, if you could take these. In the examples that you were showing, where source of these oscillations investigated? Were they before IBR connections? And then the second question, which you can take both at the same time, is that, is this a permanent solution or a temporary?
Thanks, Babak. So yes, source of oscillations were investigated, and we narrowed down to the plants that were the key contributors to these oscillations. And because they are control interactions, if we do studies only with one plant, we'll never see them. It only occurs when it is in the vicinity of other dynamic plants. But we could identify who are the main contributors to those oscillations. And before those IBRs were connected, those oscillations were not present. And in terms of second question, this retuning is permanent. In fact, I would say this retuning is solving the problem from the root, and hence this is the permanent solution, which is fixing the root cause of the problem.
Okay, all right, great. So actually, if I could ask you also, I can share your view as a generator on the second question.
Yeah, Babak, I think again, it all boils down to what are really the root causes of oscillation. And I think if you look at examples of Western Murray, which I have been in the forefront because of the issues in the Broken Hill network, we have identified that one of the key contributors to that is the appropriateness of the tuning settings, particularly in the SVC in the Broken Hill area. But of course, noting that the SVC was tuned during the times when it was the only dynamic voltage control element in the Broken Hill network, and primarily to regulate voltage for the Broken Hill loads. So the addition of the Silverton Wind Farm and the Broken Hill Solar, of course, significantly changed that voltage control strategy for the area. And so I think, so tuning, not just about inverters, but I think generally of all associated plant in an issue is actually, to me, a fundamental solution, and it can be permanent. And I think I agree with what Sachin has just commented on, that it can be relied upon in some cases to be a permanent solution.
All right, perfect. On that note, we are exactly precisely on time. So it takes probably 20 seconds for us to switch over to the last video. I'm going actually to text the link to survey. Thank you, everyone. So I think we are absolutely on time.